Okay, this is section 6.1 in our textbook, the first 9 questions that have to do with the multiplication of whole numbers with fractions. So our first question says this diagram models 3 times 6 and 1/5. So there are 1, 2, 3 groups of 6/5. Each of those groups that I underlined there is 6/5. Another way we could actually say that is 3 times 1 and 1/5. They're both the same thing because this fraction right here is either 6/5, if you want to think of it that way, or alternatively 1 and 1/5, but they're both the same thing. So when I ask the question 3 times 6/5, what I really want to ask myself is how many fifths do I have in total? I have 1, 2, 3, 4, 5 fifths, 6 fifths, 7, 8, 9, 10, 11, 12 fifths, 13, 14, 15, 16, 17, 18 fifths. So altogether, if I have one of those as being fifths, my answer would be 3 times 6 fifths would equal 18 fifths, or 1, 2, 3, and 3 fifths. Our second question, our question 4, because we skipped 2 and 3, it says what equation does each of these models represent? For pattern blocks, assume a hexagon represents one whole. So this shape right here is a hexagon, and that represents 1. So each of these 3 shapes that make up the whole are going to represent what fraction? Anybody? Each of these is going to be a third. So if I have 4 groups of 1/3, 1, 2, 3, 4, I can make 1 plus an additional third. Or more accurately, before I went to there, if I quadruple 1/3, I'd have 4 thirds, which is equal to 1 and 1/3. And finally, question B in number 4, it says 2 fifths plus 2 fifths plus 2 fifths, or 2 fifths plus 2 fifths plus 2 fifths, numerically instead of pictorially, would be 3 groups of 2 fifths. If I ask myself that magical question, how many fifths do I have in total? I'd have 1, 2, 3, 4, 5, 6 fifths, or 1, 2, 3, 4, 5, 6 fifths, or 1 and 1/5. In question 5, again, we're continuing with the same idea. If we think about A, I can either think of it as being what 2 fractions are each of these? What 2 different ways to express those fractions? It can be 6 fifths, or it can be, or sorry, not 6 fifths, 6 quarters, or 5 quarters, or 1 1/4. So we're going to go 2 groups of, and you can either say 5 quarters or 2 groups of 1 1/4. Either way you look at it, it's the exact same question. When I solve it, if I solve it improperly, how many quarters do I have? I have 1 quarter, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 quarters. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That still makes sense. Or if it's a mixed fraction, I would have 2 and 2 quarters, which is the same thing as 2 and a half, because really when I think of this rectangle, I can think of it as being a half instead of 2 quarters. Our next question gives us a space on a number line between 0 and 1. And it has 6 little spaces in here, 1 space, 2, 3, 4, 5, and 6. So because it has 6 spaces, each of these numbers represents a sixth. So there would be a number line labeled. And if each jump is a sixth, I have 4 jumps or 4 groups of 1/6, leaves me at 4/6. And if I think about what is 4/6 in lowest terms, anybody? 2/3. So if I was to cut it into thirds instead of sixths, 1, 2, 3, 4 jumps leaves you at 2/3 of a fraction, as a fraction. Question 6 asks us to draw diagrams or diminutives to solve, so we'll go with A. 4 groups of a half. I'm much luckier than you are because I can actually draw a half and then press the infinite cloner button. And then just go 2 halves, 3 halves, 4 halves. What doth 4 halves make? So if I said 4 times a half is how many halves? How many halves do I have? 4 halves. How do I write 4 halves? No, that's it simplified. How do I write 4 halves? 4 over 2. So this is 4 over 2, but we all know that that equals 2. And I can actually show it this way. Watch this. Hang on one second. Watch this. Through the magic of smartboard technology. I'm going to ungroup those, hopefully. There we go. And I can move this one over here. And I can move this one over here. And we see why 4 quarters equals 2. Amazing. Question B says 3 times 7 tenths. So if I draw 7 tenths, so if I have 7 tenths drawn here, I'm going to triple it. So there's doubling it and tripling it. So if I triple 7 tenths, the question I want to ask myself is how many tenths do I have? Isaac, how many tenths do I have in total? 21 tenths. So as an answer, 21 tenths is acceptable. As an improper fraction, if I was to give 3 of these tenths to this one, and give 3 of these tenths to this one, what is my answer as a mixed fraction? Based on the picture, 2 and 2 and 1/10. That's right, 2 and 1/10. Everyone good with that? So for question C, we have 2/3, and it says 5 groups of 2/3. So if I multiply it by 5, I'd have 5 groups of 2/3. How many thirds do I have in total here, Dawson? How many thirds are there in total here? There's 1 there, 2. How many thirds do I have? There's 5, 1, 2, 3, 4, 5 of them. 6, 7, 8, 9, 10 thirds. So my answer is 10 thirds as an improper. And if I rearrange these, oopsie daisy, let's ungroup these. Then this would make 1. This would make another. This over here would make another. What's my answer as a mixed fraction? 3 and 1/3. Oops. All right, we had some technical difficulties there, so we're going to go on to the next question. So for question 7, what it's asking you to do here, Isaac, is solve these questions without having to draw them. So here's how I solve them. For question A, 3 times 1/8. If I envision an eighth and I triple it, how many eighths would I have in total? 3/8 is correct. Okay, we just had a fire alarm, so we're back now. Question B says 6 groups of 1/4. So if you envision 1/4 and you had 6 groups of them, if you ask yourself the question, how many quarters would you have in total? What's the answer? If you took a quarter and multiplied it by 6, you'd have 6 quarters, which we'd write as 6 over 4, which is the lowest term mixed fraction, is 1 and 2/4, which is 1.5. Does that make sense to everybody without having to draw it? If I had 6/5, imagine what that looks like, and I doubled it, how many fifths would I have? 12 fifths, which is equal to 2 and 2/5. And finally, if I had 4/3 and I doubled it, how many thirds would I have? 8 thirds. And 8 thirds is equal to 2 and 2/3 as a mixed fraction. Question 8 says the width of a Canadian flag is half of its length. If the length is 4 meters long, how wide is the flag? So really what we're asking this question is, if the width is half of this, well, we're used to seeing the whole number first when we model it. We know that we can model it this way. But we also have learned, Hayden, that the commutative property of mathematics states that the order in which you multiply 2 terms does not affect the product. So given that both of these will have the same answer, we can kind of think of it like this. If we quadruple a half, how many halves would we have? We'd have 4 halves, or 2. And if I thought of it this way and I read it as being half of 4, that's even easier, because what's half of 4? 2. Either way we think about it, we get the same answer of the width is 2 meters. And finally, the last question says a minibus seats 12 people when full. It's 3/4 full. How many people? So there's their bus. It seats 12 people. I think I'm doing this wrong. 1, 2, 1, 2, 2, 1. Did I do that wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, I got it right. There's 12 full seats. It's 3/4 full. So if I ask you how many people is that going to be, what is 3/4 of 12, or 3/4 of 12? So if I think of it that way, if I multiplied 3/4 by 12, how many quarters would I have? That's a tricky question. If I have 3/4 and I multiply it by 12, how many quarters would I have? 36 quarters. So if I write the answer as being 36 quarters, what is that as a whole number? Hannah, it is 9. So therefore, if 3/4 of 12 is 9, then there are 9 people on that bus. Does that make sense to everyone? And all we did, we said, well, 3/4 of 12. 3/4 of 12 is like that. And if I think about it using the commutative property, 12 times 3/4, how many quarters? 36 quarters. Your answer is 9.